Okay, guys, welcome. Today we're going to talk about increasing and decreasing functions. Okay, so we're going to present sort of a somewhat complex definition of increasing and decreasing, but I want to sort of talk about this. It's really not as complex as it seems, and we'll show that sort of with a drawing. Okay, so in the increasing case, we say that a function is increasing if f of x2 is greater than f of x1 whenever x1 is less than x2, right? Now, the easiest way to think of an increasing function is if you move from left to right, if a function is increasing, the graph will rise. Now, I want to sort of expand this definition a little bit. All right, now we're saying that x1 is less than x2, right? So that was one thing in our definition. And now we're also saying that f of x2 is greater than f of x1, which just means that if I have some function, f of x1 is down here and f of x2 is up here, right? F of x2 is bigger. But f of x2 means that's what I get when I plug in x2, and f of x1 means that that's what I get when I plug in x1, right? So of course, if these were connected, we would see that that's an increasing function. Right? And then similarly, we say that a function is decreasing if f of x2 is less than f of x1, right? Or again, usually we think of it as if we move from left to right, it's decreasing if the graph falls or goes down, right? So then that case would look something like this. So here's x1, here's x2, but now this time f of x1 is bigger. Right, and again, this is what happens when you plug in f. This is what happens when you plug in x2 into f, and you see that you're going to fall. And then, of course, we say that it's constant if it's equal, right, if it doesn't change. So in that case, the graph would just look like a horizontal line connecting f of x1 and f of x2. Right, and of course, the thing of it is if you move from left to right, you're not going up or going down. Okay, so to determine where functions are increasing and decreasing, you have two options. You can either use calculus or you can look at the graph. Now, since we don't know calculus, we're going to go ahead and we'll look at the graph. So now in part A, we have a parabola, right? And actually in part B, we do as well. Right, so we see that we have f of x is 1 minus x squared. So let's go ahead and we'll plot a couple points. Okay, so if we plug in -2, we're going to get a 1 minus 4, so we're going to get a -3. If we plug in -1, we get 0. If we plug in 0, we get 1, and then we come back down. 1 minus 1 is 0, and then 1 minus 4 is -3. Okay, so if we plot our points, we have -2 comma -3, so that's here. -1 comma 0 is here. 0 comma 1 is here. 1 0 is here, and 2 -3 is here. All right, so hopefully by looking at the graph, you can see that on this side, it's increasing because as we move from left to right, or as if we travel this way, we're going up, and then on this side, you're decreasing. Right, because as you move left to right, you're going down. Right, now we want to be a little bit more careful about how we word this. So there's a couple ways you can do that. You can say that it's increasing when x is less than 0, and that would talk about the left side of this graph, and it's decreasing when x is greater than 0, right? Or if you wanted to in interval notation, you could say that it's increasing from -infinity to 0, and it's decreasing from 0 to positive infinity, right? Technically at 0, it's neither increasing nor decreasing. If you include it in those brackets, I guess it's not technically wrong, but it's not technically right either. I usually don't include it, but usually it's not made a huge difference one way or the other. Okay, in part B, we have that g of x is equal to x squared plus 2x. All right, so let's go ahead and we'll plot some points. So we go -2, -1, 0, 1, and 2. Okay, so if we plug in these points, -2 would give us a +4, -4, so a 0. If we plug in -1, we get a 1 minus 2, so a -1. If we plug in a 0, we get 0. If we plug in 1, we'll get a 3. Yeah, we get a 3. And if we plug in a 2, we'll get a 8, right? One, 2, 3, 4, 5, 6, 7, 8. Okay, so at -2, we have 0. At -1, we have -1. I forgot to put a point there, but that's okay. And then we have 0. We have 1, 3, and we have 2, 8. So we get something like this. Right, so now here we see that this is sort of the key point. Right, to the left of that, we're decreasing. And to the right of that, we're increasing. Okay, so it looks like that we're decreasing when x is less than -1 and increasing when x is greater than -1. Or we could say it's decreasing on -infinity to -1 and increasing on -1 to infinity. All right, so that's the idea there. Okay, now let's look at how this comes into play for piecewise functions. Now, in part A, we're told that this graph is going to look like the absolute value of x when x is less than or equal to 2. All right. Now, if you look at some values for absolute value of x, you're just making everything positive. So this would be 2, this would be 1, 0, 1, and 2. So you're going to get, for the absolute value part, you're going to get something that looks like this. I want to include that since it's a closed circle. So we get something like this. And on this side, we have an arrow. All right, but once we get to 2, we jump down to -3. And since it's an open circle, or sorry, since there's no equal sign, it's an open circle. And then it just stays at -3 for the rest of it, right? So it looks like we now have 3 pieces of this. We're now decreasing when x is less than 0. We're increasing when x is between 0 and 2. And we're constant for x greater than 2. All right, and again, you could put these in interval notation, but we'll just leave it as that. Okay, and then part B, we have some lines, so that will make graphing a little nicer. So we know that when we're less than -1, we're at 2x plus 1. So if I look at 2x plus 1, and let's say for -1, even though we know it'll be an open circle in -2, then we're going to get a -1. All right, 2 times -1 is -1 plus, no, sorry, -2, and then plus 1, we get -1. If we plug in a -2, we get -4 plus 1, so -3. All right, so for the 2x plus 1 part, we're going to get something that looks like this. So I have an open circle on -1, -1, and of course, closed circle for -2, -3, and this section will look something like that. Now, if we're between -1 and +3, we're just at 0, right? And this is both inclusive. So we have a closed circle here, we have a closed circle here, and it's just right on 0. Right? And then finally, if we're greater than 3, we're at -2x plus 1. Which if we plug in 3, even though it's an open circle, and 4, we're going to get so 3 times -2 will be a -6 plus 1 is a -5. And then 4 will give us a -8 plus 1, so -7. 4, 5, 6, 7. So for that part, we'll use a different color. Let's use red, sure. So then when we're at 3, we're at -5. 1, 2, 3, 4, 5. And of course, an open circle again. And then when we're at 4, we're at -7. So something like this. Right? So it looks like we're decreasing just on the last part. That's when x is greater than 3. We are constant when x is between -1 and +3. For constant, we can sort of include those endpoints. You don't necessarily even have to. And then we're increasing on the first part. So when x is less than -1. All right, so that's the idea there. Okay, now I believe, so these are the last 2 examples, and these are a little bit interesting. All right, so now in part A, we have f of x is 1 over x. Okay, now right away there is a little bit of an issue, because if you go to test -2, -1, 0, 1, and 2, there's a problem with one of these, right? Now these are okay because you get -1/2 and -1, but for 0, that's undefined because you can't divide by 0, right? And 1 is 1, and then 1 over 2 is 1/2 again. So if we plot what we have, let's see what we have. Now, if we plug in -2, we get a -1/2. So that's something like this. At -1, we have -1, so that's here. At 1, we have +1, and at 2, we have 1/2. Right? Now, what's going to happen here, and we'll spend more time on this sort of in another chapter, but as you make your x bigger, whether it's positive or negative, you're making a small fraction, right? Because, for example, 1/4 is smaller than 1/2, 1/8 is smaller than 1/4, and so on and so forth. So as you get further away from 0, you're going to get closer and closer to this axis, but you're never going to get there. You're just going to get to really small numbers, but never get to 0, right? And then here, the same thing happens, except you're negative. Now, what happens if you plug in a really small number that's not 0, right? So say if you plug in, what about x equals 1/2? Well, then you get 1 over 1/2, which if you do keep, change, flip is 1 times 2, so you get 2. So when x is 1/2, you jump up to 2. And if you think about it, when x is 1/4, what's going to happen? You're going to get 4. So as you get close to the y-axis, you're going to get larger and larger, right? But we know we can't plug in 0 because it's undefined. And a similar thing will happen down here, right? So those are sort of interesting graphs there. And then, of course, this function is decreasing in 2 separate pieces. It's decreasing from -infinity to 0, and you will union that with 0 to infinity. And of course, we can't say that it's decreasing the entire time because at 0, it's undefined. So we can't say anything about what happens at 0. So that's sort of a break in the action there. And now in part B, we have 1 over x plus 4, and this should be like equal to f of x or y or something. But let's go ahead and we'll take a look. Now here we can see that if you were to plug in -4, that would be the trouble point, right? So we'll plug in some points around that and see what happens. We know that -4 is undefined. But if we plug in a -5, we're going to get that that is a -1. If we plug in a -6, that's the -1/2. If we plug in -3, that's a 1, and -2 is a +1/2. So this graph is going to look similar, except it's sort of shifted over. Right, so got to go 1, 2, 3, 4, 5, 6. And we'll get something like this. So at -6, we're at -1/2. At -5, we're at -1. We know that at -4, we sort of have that trouble point. So I'm going to put an asymptote there. And we'll talk more about that later on. And then at -3, we have +1. And at -2, we have 1/2. So we're going to get essentially the same kind of deal as before, like I said, except we're just now shifted over. So something like that. Okay, so that concludes this video on increasing and decreasing functions. Hope you enjoyed it, and I will see you next time.